Solar geoengineering to cool the planet, is it worth the risks? As the planet continues to heat up, the world is searching for bold solutions to fight climate change. One of the most controversial ideas gaining attention is solar geoengineering. The basic idea? Reflect a small portion of sunlight back into space to cool the Earth. It sounds like science fiction, but it's grounded in real science. And it might become part of our climate strategy sooner than we think. Let's break down how it works. Solar geoengineering involves techniques that reduce the amount of solar radiation absorbed by the Earth. The most widely studied method is stratospheric aerosol injection. This involves spraying tiny reflective particles, like sulfur dioxide, into the upper atmosphere. These particles act like mini mirrors, bouncing sunlight away from the planet. A real-world example comes from nature: the 1991 eruption of Mount Pinatubo in the Philippines. That eruption released 20 million tons of sulfur dioxide into the stratosphere. The result? Global temperatures dropped by about 0.5 degrees Celsius for nearly 2 years. This event gave scientists a glimpse into the cooling potential of aerosols. Now, research groups are exploring how to replicate that effect in a controlled way. According to Harvard's Solar Geoengineering Research Program, injecting aerosols could potentially lower global temperatures by 1.5 degrees Celsius. But with potential benefits come serious questions and risks. One major concern is unintended climate disruption. Cooling the Earth unevenly could alter precipitation patterns. Some regions might see reduced rainfall, while others face more intense storms or droughts. There are also worries about ozone depletion. Certain aerosols, especially sulfur-based ones, can damage the ozone layer. That would expose life on Earth to more harmful ultraviolet radiation. Another concern is termination shock. If geoengineering is suddenly stopped after being used for years, the planet could rapidly heat up. The rebound effect could be worse than if no intervention had happened at all. And then, there's the question of governance. Who gets to decide if, when, and how geoengineering is deployed? What if one country acts unilaterally? Could this spark geopolitical tension or conflict? A 2023 report by the Intergovernmental Panel on Climate Change, IPCC, emphasized that solar geoengineering is not a replacement for cutting emissions. It can complement, but not substitute, the hard work of reducing greenhouse gases. Right now, most research is still in the modeling phase. A few small-scale field tests have been proposed, such as the SCOPEX experiment by Harvard. This experiment aims to test balloon-based aerosol dispersion in the stratosphere. So far, tests have been paused due to public backlash and the need for better regulation. Public opinion is mixed. A 2022 survey by Nature Climate Change showed that only 33% of global respondents supported geoengineering, while over 40% expressed concern or opposition. People worry that focusing on solar geoengineering could delay meaningful action on emissions. So what's the case in favor of it? Supporters argue it could buy us time. Climate tipping points, like the loss of Arctic sea ice or collapse of the Amazon rainforest, could happen before we reach net zero emissions. Geoengineering might slow those changes, giving humanity a buffer to decarbonize. It could also reduce the risk of climate feedback loops, such as methane release from thawing permafrost. These feedbacks could accelerate warming beyond our ability to control it. But critics stress that even if solar geoengineering works technically, it raises major ethical concerns. Should we alter the entire climate system to fix a problem we created? And how do we ensure the poorest countries, often most vulnerable to climate change, aren't harmed by unintended side effects? The answer may lie in transparency, global cooperation, and careful governance. Experts suggest developing an international framework to study and potentially regulate geoengineering. This would ensure research is open, monitored, and aligned with global climate goals. In the end, solar geoengineering is not a silver bullet, but it could become one piece of a larger climate toolbox, one that includes aggressive emissions cuts, carbon removal technologies, and adaptation strategies. The question isn't just can we do it, it's should we? And if so, how, when, and under what conditions? Because while solar geoengineering might help cool the planet, it also forces us to confront deep questions about risk, equity, and responsibility. And in the race to save Earth's climate, the biggest challenge may not be technology. It may be trust,